So you hear that sound. That's not your typical factory floor. It might just be the future sound of building homes. Welcome to the deep dive.
Hello.
Today we are really digging into autonomous bricklaying, specifically in housing.
Yeah, that's right. We're looking at this really interesting case study from cognitive market research. It details how one real estate developer actually decided to, well, bring robots onto their construction sites.
Fascinating stuff.
It really is. And this report, it gives us a great window into how one company's tackling some, pretty persistent challenges in construction.
So our mission today, for you listening, is to unpack how this automation is shaking things up.
Exactly. We want to understand the impact on efficiency, on costs, and maybe even on the bigger picture like affordable housing. We're here to sort of extract the key insights for you.
Okay, let's start at the beginning then. Yeah. What were the core problems? What pushed this developer towards robots in the first place?
Well, the report highlights a few really big pressures they were under. Number one was a serious need to boost their construction productivity, just get things built faster.
Right.
They were hitting bottlenecks, seeing delays, mostly because they relied so heavily on skilled human masons.
Okay, and that reliance, I assume, hit the bottom line, especially for affordable projects.
Absolutely. It made keeping costs down, for affordable housing increasingly difficult. Plus, you had rising labor costs generally.
Yeah, that makes sense. A classic supply and demand issue with skilled labor, maybe?
Yeah.
And what about the actual quality of the work?
That was another major point. The report talks about inconsistent workmanship. It's just natural, right? Human skill levels vary, people make mistakes.
Sure.
And that inconsistency can lead to, structural issues needing rework, which costs time and money.
So you've got speed issues, cost issues, quality control.
And on top of all that, they were facing a growing shortage of experienced bricklayers, just fewer skilled people available, which, of course, just made all the other problems worse. Longer construction times, budgets getting inflated. It was becoming a real hurdle.
Okay, so a pretty compelling set of reasons to look for alternatives. How did they actually, bring the robots in? What did their approach look like? It wasn't just dropping robots on site, presumably.
No, definitely not. It was quite a multifaceted strategy. A really key part was adopting modular construction methods alongside the robot.
Modular, so building parts elsewhere.
Kind of. They started using the robots to lay bricks on prefabricated modules, often off-site. So imagine sections of walls being built with robotic precision before they even get to the final building location.
Ah, I see. So it speeds up the on-site part dramatically.
Exactly. Much faster assembly on site and less need for manual bricklaying there. Plus, this approach gives you inherently much better accuracy and consistency right from the start.
Interesting. Like manufacturing parts of the building. Okay, what else was involved besides the modular aspect?
They also brought in AI specifically for the design phase. They used machine learning to crunch data from past projects.
Do what? Optimize the brick usage?
Precisely. The goal was to figure out the most efficient wall designs, how to use the fewest bricks possible without compromising structural strength at all.
Okay.
The AI basically looks at tons of data on structural integrity, material properties, and spits out the optimal brick layout for different walls.
Cover.
Yeah, and they didn't just trust the algorithm blindly. They ran advanced simulations to test these optimized designs rigorously before building anything physically.
So smart planning up front using AI, combined with the physical robots, how do they scale this up to actually make a dent in, say, housing demand?
Right, good question. That's where their scalable deployment strategy came in. They didn't just test one robot. They rolled out multiple units across different sites at the same time.
A whole fleet of them.
Pretty much. This let them work on several projects in parallel, significantly boosting their overall housing output. And crucially, it helped them get around that bottleneck of limited human bricklayers.
Makes sense. You can build more if you're not constrained by the number of available masons. Now, what about keeping these machines running? Robots need maintenance, right? Downtime must be a concern.
Absolutely. And they planned for that. They set up a pretty sophisticated cloud-based system. Think remote monitoring and, importantly, predictive maintenance.
Predictive. So it tells them before something breaks.
Exactly. The system doesn't just say on or off. It's analyzing performance data, speed, consistency, things like that in real time. It flags potential issues, maybe a part wearing out, so they can schedule maintenance before there's an actual breakdown.
Minimizing that unexpected downtime.
Right, which avoids those costly repairs and keeps the construction schedule on track. It's about proactive management.
Okay, so it sounds like the robots are doing the heavy lifting, literally. But you mentioned a cost-effective labor strategy. Did that mean human bricklayers are just out?
That's a really important point, and no, that wasn't the strategy described. It wasn't about total replacement.
When?
Instead, it was more about reallocating skilled human workers. They moved people towards the finishing stages of the projects.
Finishing stages like?
Things like interior work, electrical plumbing, detailed quality checks, tasks that need that human touch, dexterity, and judgment.
Ah, okay. So you reduce reliance on the very specific, maybe more expensive, skill of mass bricklaying.
Exactly. But you keep the valuable human expertise for other critical parts of the build, ensuring the final quality is high. It's more of a hybrid approach, optimizing both the robot's precision and the human's skills.
That sounds, well, more practical, maybe more sustainable too.
Yeah.
Okay, so we've got the problems, we've got the quite detailed solutions. What about proof? Does the report offer hard data that this actually worked?
It does, and some of the numbers are pretty striking. Let's talk productivity first. They measured a 200% increase in the daily volume of bricks laid compared to the traditional manual way.
200%. That's
Yeah.
huge. Doubling the output.
It's a massive jump. And a big reason for that is the robots can just keep going, right? They operate continuously, 247 if needed, no breaks.
Okay, a definite game changer on speed. But was it just faster? Or was the quality better too? Sometimes speed comes at a cost.
Good point. But the data suggests quality improved as well. They had automated quality control built into the process, checking standards at every layer.
Built-in checks.
Yeah. And post-construction inspections showed significantly fewer structural defects, fewer misalignments compared to manually built projects.
Which means less rework, I suppose.
Exactly. Less need for that expensive, time-consuming rework later on.
So faster and more accurate, that's a compelling combo. What did this do to the budget? Did the tech investment actually pay off in cost savings?
Yes, according to the analysis in the report, they reported a 25% reduction in overall labor costs.
25%.
Mm.
Mostly from needing fewer bricklayers.
Primarily, yes. But beyond labor, they also saw a 15% decrease in total project expenses.
15% overall. How?
Well, partly the labor savings, but also attributed to the increased efficiency, less material waste because of the robotic precision, for instance. And the data really paints a picture of this not just being innovative, but actually being an economically sound, viable approach for the long term.
Faster, better quality, and cheaper.
Yeah.
It sounds almost too good to be true. What were the sort of broader results or impacts beyond just one company's bottom line?
Well, perhaps the most significant outcome highlighted is the potential impact on affordable housing.
How so?
By making construction faster and cheaper, this technology could genuinely help developers provide more housing units at more affordable prices. It's a direct link between a tech advancement and tackling a major societal need.
That's a really powerful connection to make. Tech, not just for tech's sake, but for social benefit.
Yeah.
Any other big outcomes noted?
Definitely. On a business level, by adopting this tech early, the company positioned itself as an innovator, a leader in the construction sector.
Right. Good for the brand.
Enhances their credibility, probably attracts new investment, partners, clients who want these, forward-thinking solutions. It shows they're committed to efficiency and progress.
So it's about future-proofing their business, too, not just solving today's problem.
Precisely. The success they saw with this model, it basically gives them a blueprint for sustainable growth. They've proved it works.
So they can scale it.
Yeah, they're better positioned now to expand into new areas, take on bigger projects, and really cement that competitive advantage they've built.
Okay, this has been really insightful. Let's try and crystallize the main points for everyone listening. What are the absolute key takeaways from this deep dive?
Sure. If we boil it down, I think there are a few core things. First, it's clear. Robots can seriously speed up construction and save significant money. That 200% productivity jump is hard to ignore. Second, using AI alongside the robots helps ensure really high quality and consistency, reducing errors. Third, this isn't necessarily about replacing all humans. Robots handle the repetitive, heavy stuff.
Freeing up people for more complex work.
Exactly. And potentially making sites safer, too. Fourth, there's a sustainability angle. The precision means less wasted material, potentially greener construction.
Good point.
And finally, maybe the biggest takeaway is that this kind of tech, robotic bricklaying looks like it could be genuinely vital for large-scale development, helping us meet those huge, growing needs for housing and infrastructure.
So for you, the listener, those numbers really stand out, that doubling of speed, the 25% labor cost cut. It shows how automation is moving beyond factories into industries like construction. potentially making things like affordable housing more achievable.
Yeah, it really provides a shortcut to understanding this shift, and it makes you think, doesn't it?
How so?
Well, it raises a question for you to chew on. We've seen what robots and AI can do for bricklaying here. What other parts of building a house do you think are next in line for this kind of automation? And what might the wider ripple effects be for society beyond just making things faster or cheaper?
Hmm. Definitely food for thought. What does a fully automated construction site even look like? Lots to consider. Thanks for taking this deep dive with us.